as you're going to see from this short little video about molar mass determination, this process is quite straightforward. The determination of molar mass is absolutely essential for chemistry, especially quantitative chemistry, and so it is something you do need to be adept at. And so let's have a look. So as it says here, molar mass refers to the mass in grams of 1 mole of a chemical entity. And what is a chemical entity? Well, in this context, it refers to atoms, molecules, or formula units. If you remember what a formula unit is ionic. So that's something like NaCl. So a formula unit refers to the simplest whole number ratio of elements in an ionic substance. All right, just to clarify that. So the molar mass is numerically equivalent to the atomic mass. What shows up on the periodic table is the atomic mass in AMU. And so you have some number of that particular element. Well, the molar mass is numerically the same, but it refers to a mole of that element, not one of that element. Okay, so the molar mass is found in the periodic table, and the molar mass of any compound then, molecule or formula, is found by adding up the molar masses of all of the atoms. Okay, so we do that from a chemical formula, and so you do need your periodic table when you're determining molar mass. And the other thing you have to remember is nomenclature, or naming, and so you have to be able to take a chemical name and put it into the correct chemical formula. Okay, so in terms of molar mass, then you just have to look in your periodic table and look up molar masses. So what is the molar mass of argon? Well, if we looked on our periodic table, we'd see argon here, and so there is the atomic mass, and so we just have to write that, but we use the capital M, which means molar mass, and we can just write that down. Then it was 39.95 grams per mole, because it's 1 mole, molar mass. So pretty straightforward. Well, what about if you want to find the molar mass of carbon tetrachloride? So as I said, this is where you have to add things together. So there is some pictures from the periodic table, and so we want to determine the molar mass of carbon tetrachloride, and as it does say here in the question, this is important, show your work. So in this instance, if that's the question being asked, you need to write it out. So we're looking for molar mass, carbon tetrachloride, CCl4, and it equals the sum of the molar masses of all of the elements. So we have 1 carbon, so it's going to be molar mass of carbon plus 4 times the molar mass of chlorine, because there's 4 chlorines, and we just write in the numbers, so 12.01 grams per mole plus 4 times 35.45 grams per mole, and we do the math on that, still 12.01 with one of them. 4 times the molar mass of chlorine is 141.60, and so the molar mass of carbon tetrachloride in total is 153.81 grams per mole. So as it suggests, the sum of the molar masses of all of the elements in the compound. Now, what is the molar mass of ammonium phosphate? Again, show your work. So this is a little more complicated, mainly because of the formula. Now, if you think for a minute, can you come up with the formula for ammonium phosphate? So here's the formula for ammonium phosphate. It is NH4 3PO4. So remember, the ammonium ion is NH4 plus, the phosphate ion PO4 3 minus, and so putting it all together, you need 3 ammonium ions to balance. So that's what I mean by having to remember your nomenclature. And again, it does say show your work, so we're going to show our work. So molar mass NH4 3PO4 equals molar mass of nitrogen, but there's 3 of them, so it's 3 times molar mass of nitrogen. There's actually 12 hydrogens, so it's 12 times molar mass of hydrogen. There are is only one phosphorus, so it's a molar mass of phosphorus, and there are 4 oxygens. So 4 times the molar mass of oxygen. And so we're going to write that out. So that's 3 times 14.01 grams per mole plus 12 times 1.01 grams per mole plus the molar mass of phosphorus, which it says is just 30.97 grams per mole plus 4 times 16.00 grams per mole. So again, there's the sum of the constituent elements in the compound in the formula. And so we would do the math on those: 12 times 1.01, 4 times 16, 3 times 14, and we add them all together, and we come up with the molar mass of ammonium phosphate that is 149.12 grams per mole. And so same thing, just a little more complicated because it is a slightly more complicated formula. Now there's another way you can try this, and we'll do that right now. So this is a really quick little way to assist you in calculating a molar mass. We're going to do the molar mass of ammonium phosphate again, NH4,3PO4, but we're going to do it online using an online molar mass calculator. So let's go online. This is where you need to go. Front page, your Moodle page, grade 11 chemistry, general important stuff, molar mass calculator. So that's where you're going, and you click on that, and not surprisingly you get a molar mass calculator. This is from the University of Sydney in Australia, and all you do is type in the formula, but you do have to do it faithfully. That is brackets, capital letters for your elements and the correct number, and that's all you do. NH4, whoops, I forgot 3, NH4 3PO4, and then you just hit calculate, and away you go. And so there you go, molar mass of ammonium phosphate as shown. 1 mole equals 149.0869 grams. Round that to 2 decimal places. I've told you should probably do 149.09 grams per mole is the molar mass of ammonium phosphate. And so you don't have to show your work here, but you do still have to write it down, so I'll write it down right now. And there it is. Molar mass of ammonium phosphate, 149.09 grams per mole. So that's a place you can go if you're interested in trying to save a bit of time calculating your molar masses. You still have to know how to do it, you still have to show your work, but when you're not called on to do that, you can always go to this particular tool to do it. And finally, what is the molar mass of copper 2 sulfate pentahydrate? Well, there's the formula: copper Cu, sulfate SO4, both have charges of 2 plus and 2 minus, so copper 2 sulfate pentahydrate, 5 times water. This is a hydrated compound, a hydrate. And so when we do the molar mass is the sum of all the constituents, so the molar mass of copper 2 sulfate plus the sum of 5 times water. And so we would add all those together, and the molar mass of copper 2 sulfate is 159.62 grams per mole, and the molar mass of water is 18.02, so 5 of them would add up to 90.10 grams per mole. So the molar mass of copper 2 sulfate pentahydrate is 259.72 grams per mole. And so really the take-home message when this one is the water in a hydrated compound is part of the molar mass of the compound. So don't forget to put in the hydrates when you do that. And so that's it for calculating molar mass.